In this video, we're going to start talking about how we find the slope at any point on a curve. First of all, I wanted to find this particular limit, and we'll explain why this limit is so important. So we did one like this the other day. Let me start by just expanding the x plus h squared. So it becomes x squared plus 2xh plus h squared. Multiplying that by 4. Okay. Multiplying into those parentheses, we get 4x squared plus 8xh plus 4h squared. Four x squareds cancel out. I can now factor an h out. These h's divide out to be 1. Now, once that happens, I try and plug 0 in again for h, so I get an answer of 8x. Okay. This is our limit. Now, keep that in mind. We're going to use that in a moment. This is a graph of 4x squared, and I wanted to talk about how we're going to find the slope at any point. So let's say we wanted to find the slope at 1. Okay. Now maybe you'd start by doing the slope from 0 to 1. So you'd say, okay, well, this is the point 0, 0. This is the point 1, 4. So 4 minus 0 divided by 1 minus 0, we get a slope of 4. Now this is called a secant line. And a secant line just has 2 points on a curve and connects them with a line. And important to note, it's not the slope at 1. Here's the slope at 1. It's less than that. But it's not a terrible estimate. But we could make a better estimate if we were willing to try maybe a different point. So maybe instead of 0, 0, we try this point. We connect that and make a secant line. Right, 0.5 and 0.5 squared, this is 1. So now we'd find the slope. 4 minus 1 is 3, divided by 1 minus 0.5, so 3 divided by 1/2 is 6. And again, we're getting better. But of course, the point is that we really want to find, we really want to just keep moving these points up until the difference between the point that we want, 1, 4, and the other point we're evaluating is 0. We really don't want there to be a difference. So essentially, we're taking a limit. We're going to keep moving this point over further and further up the curve, make the secant line get closer and closer. We'd love for it to be 0. Okay. Now the difference between the point we pick and the point we want, we call h. Okay. So let's just think about this. If we picked a point, and I'm going to go to the other side of the graph just so I have a little room to draw. Let's say we picked a point and we said, I want to find the slope at this x. So to find the slope, we need this point, which the x-coordinate's x, and the y-coordinate is whatever we get when we plug x in. Well, to find the slope, I then evaluate maybe another point really close. How close? Well, let's call it h units away. Let's call that h. So this is the x-coordinate x plus h. Well, then the point is x plus h and f of x plus h. And to find the slope, we do the difference in y's divided by the difference in x's. See, the x's cancel. And we'd love to do the limit as h approaches 0, because we'd like h to get so small. Well, this is what we've been doing the previous couple days and videos. It's just finding that limit. You recognize the h going to 0 and divided by h, I hope. This is just finding the slope. And these equations we're getting, like 8x, that's our slope finder. we're going to be able to find the slope at any point on the curve using that. And again, this is just the definition of slope, where we're just evaluating 2 points h units apart. So make sure you see that this is just slope down here, and we're evaluating 2 points h units apart, but we'd like h to get smaller and smaller. So our slope finder, let me just write slope finding equation for this one was 8x. Okay, it was the limit we'd evaluate. And the beauty is now we can use that and it works for everything. Okay, find the instantaneous rate of change. By the way, this just means slope. Okay, lots of different ways to ask the same thing. So we just plug in 1. 8 times 1 is 8. Find the slope at 3. 8 times 3 is 24. So at any point I pick, all I need to do is multiply it by 8. Now, a tangent line. A tangent line is a line that touches a point, touches an equation at one point, and at that point has the same slope. And I have a picture I'm going to show you, but let's get the equation first. So the line tangent to x equals 1. For every line you need a point and you need a slope. So I need to know the slope of the curve. Well, I already did that, but it was just 8 times 1. To get the point on the curve, I plug 1 into my original equation, so it's just f of 1, which if you go back up there, 4 times 1 squared is 4. So my tangent line is 8 times x minus 1 plus 4. On the next slide, I'm going to show you the graph. Here it is. This is the graph of 4x squared like you saw before, and here's the line, the tangent line. 8 times x minus 1 plus 4. Notice that they touch at one spot, and at that spot they have exactly the same curve, or the same exact slope. Okay, so that's why we wanted to find the slope of the curve using our slope finding equation and the point that they'd meet at. Now the other thing you could be asked about is a normal line, and a normal line is just perpendicular to the tangent. So in our case, our tangent line was 8 times x minus 1 plus 4. So our normal line would be negative 1/8 times x minus 1 plus 4. Because we just need the opposite reciprocal slope. And that, if we graphed it, would hit the same point, but it would be perpendicular, something like that. Now, that is extremely useful when it comes to some physics applications. On the previous video, the last lesson, we looked at this particular limit, and we came up with negative 1 over x squared. So I just want to point out this is the slope finder for 1 over x. Okay, because you see here we have our f of x plus h minus f of x all over h. So the slope finder for 1 over x is negative 1 over x squared. So if I said, what's the slope? Remember, same thing, instantaneous rate of change. At 1, be negative 1 over 1 squared, which is negative 1. What's the instantaneous rate of change at 1/2? Negative 1 over 1/2 squared would be negative 4. So at any a, we just plug in a. It should be a squared. Where does the slope equal 1? Well, this is kind of a fun question. First thing I want you to notice is up here, we've got a slightly negative slope, getting more negative, very negative. Here we've got a very negative, getting less negative, not negative. So where's the slope equal to 1? Well, it should be nowhere. Slope's always negative, never positive 1. And I just wanted to show you how the algebra bears that out. So if I set my slope finder equal to 1, and I'm solving, I want to know what x it's equal to 1 at. I cross multiply, I get negative 1 equals x squared. And you go to take the square root and you run into imaginary numbers. So there is no solution to that. On the next video, I'm going to do a full example, start to finish, on how to find the slope finder and use it.